Hello and welcome back to lesson 2.5. We're going to learn about measures of the center of data. And we've looked at data visually in a couple different ways in chapter 2 in the different lessons, but now we're going to look at some numerical ways to measure them. And so today we're going to learn how to find the mean of a data set, how to find the median of a data set, how to find the mode of a data set, and how to find the weighted mean of a grouped data set. So there are three measures of central tendency that we will discuss in this course. The first is the mean, and we also call that the average. And you'll notice down here, the words mean and average are often used interchangeably. The technical term is arithmetic mean, and average is technically a center location. However, in practice among non-statisticians, average is commonly accepted for arithmetic mean. And so the mean is usually considered the center of the data, but it's not always a data point. It sometimes can be, but sometimes it's kind of like if you were just to take all of your data and smooth it out and just make sure, like if you were sharing something with all your friends, you'd make sure that everybody got the same. That's kind of how we think of the mean. The median, also known as our Q2, which you learned about in lesson 2.3, is the value where 50% of the data falls below and 50% of the data lies above. The mode is the most frequent value in the data set. So it's the one that we're going to use the least. If we have some symbols for these, the mean has a symbol, a population symbol, and that symbol for a population mean when we have all of the data values of everyone in the population, then we're going to use this Greek letter mu. And if we have only sample data, the sample mean is going to be described with this symbol here, and we pronounce that X bar. So one of the requirements for the sample mean to be a good estimate of the population mean is for the sample to be taken to be by truly random methods. So we have to decide what is the best measure of central. Best measures of central tendency and dispersion can be found here. So we're going to talk about dispersion in lesson 2.7, but this is our best measure of center. So if our graph, when we look at it, is a shape of from our histogram is symmetric, then we probably know that our mean and median are about equal. Or if we have our data that says our mean and median are equal, then our best measure of center is the mean. If our data is appearing to be skewed left, where it's kind of thin onto the left, then usually our mean will be less than our median. And if our mean is significantly less than our median, we're going to use the median as our best measure of center. And we're going to say that our data is skewed left. And then if our data is skewed right, our mean is greater than our median. And again, our best measure of center is the median. So we're going to learn how to find the mean and median by using Desmos and Google Sheets. So again, if you have a small data set that you can type into Desmos, Desmos is probably the easiest to use. You're going to click on the plus button to start a table. You're going to enter your data into X1. And then the mean is found by just typing mean, parentheses, and where your data is in X1. And your median, you can find just the median by typing median and X1 in parentheses, or if you do the stats, that's when you're getting the 5-number summary, and the median is already included in that output. Now, if you wanted to find the mean and median in Google Sheets, you're going to click on any cell, and to do the mathematical calculations in Google Sheets, you always have to use an equal first and then tell it the command. So for the mean, it would be equal, and then the word average, and then parentheses, and then you're telling it what cell to start at, so A2, and what cell to end at. And then the median would be similar, except we were going to type equals, and then median, and then the cell to start at and the cell to end at. And I will show you this. If you go to our data here, So let's say I wanted to find the mean of the number of siblings that you have. We would type equals in any cell and then type average. And lots of different options will come up. Just use the regular one and then a left parenthesis and then and then you can grab your data if you want and drag all the data that you want. That's kind of nice when you have a big data set. And just make sure that it does say the values that you want. So I clicked on it and there's my average, but up here in the command bar is where I'm going to check to make sure I did include the data that I wanted. And then I can also do the median by typing equals and a median in the parenthesis. And then I can go and just grab the data like we did last time and close the parenthesis and hit enter. So it's pretty cool. So for our really large data sets in your project, it might be helpful to do some of your calculations in Google Sheets. Okay. So let's look at example one. Example one says the following data show the number of months patients typically wait on a transplant list before getting surgery. The data are ordered from smallest to largest. Calculate the mean, the median, and the mode. So we already have the data in a Desmos link that you can find in Canvas. So the only one that you cannot do in Google Sheets or in Desmos is the mode. You have to hand count that. And so we have to count, let's see, it looks like there's a lot of sevens. We've got 1, 2, 3, 4 sevens. We've got 1, 2, 3, 4, 5 tens. And we've got 1, 2, 3, 19s. It looks like 1, 2, 3, 4, 24s. It looks like we have 5 tens. So 10 is the mode. So let's head over to Desmos here and look at our data. So I have it pulled up. So we're going to go to the transplant list. And so there's my data for the transplant list. And then I just typed mean of X1 and median of X1. And it looks like the mean is 13.95. I'll round it to 2 decimals. And then the median is 13. So the best measure of center, they're pretty equal. So I would say either the mean or the median, probably choosing the mean because they're symmetric. So the mean is approximately equal to the median. And so we could say that the distribution is approximately symmetric. And I would say the mean is your best, the mean is the best measure center for this data set. In example 2, it says in a sample of 60 households, one house is worth $2,500,000. Half of the rest are $280,000. All the others are worth $315,000. Which is the best measure of the center, the mean or the median? And how did you make your choice? So we have this one house at $2,500,000 here. And that says half of the rest are at 280. So we've got a bunch here. So this must be if there's 60 households, we've got the one here, and that means there's 59 left. And so that means there's about not quite 30 that are at 280,000. And then all the rest are right here at 315,000. And then you've got this one. And so the mean is not resistant to outliers. The mean is very much affected by extreme values. The median is resistant to outliers. It's not affected. And so we would choose the median because the data is skewed. Let's look at example 3. Example 3 says the number of books checked out from the library from 25 students are as follows. So we have the 0 here and then the rest here. And it's asking us to find the mean, the median, the mode. So let's look at the mode since we have to do that by hand. We've got 3 zeros, 1, 2, 3, 4 sevens, 3 8s. So it looks like 7 is the mode. So let's go to Desmos and see what we have. I'm going to go up here and turn this off. This looks like the library. So it looks like the average number of books checked out is 6.16 and the median is 7. So they're fairly close, but we could also just type box plot and put the data in there. And that's the cool thing is the box plot will show if you have any outliers. And it doesn't look like we have any outliers. It looks a little skewed left, but not too much. So I would say it's symmetric. Okay, let's read number 4. It says 5 credit scores are given. The data set is bimodal because the scores of 680 and 720 each occur twice. Consider the annual earnings of workers at a factory. The mode is 25,000 and it occurs 150 times out of 301. The median is 50,000 and the mean is 47,500. What would be the best measure of center? Looks like this should really be a different example. I think I was just acknowledging that this is bimodal. So this is the actual example here. It says the mode is 25,000 and occurs 150 times out of 300. The median is 50,000 and the mean is 47,500. What would be the best measure of center? I would say the mode for sure, because that is definitely the best measure of where most of the data is. And it occurs half the time. The median is at 50,000 and the mean is at 47,500. So I would definitely say the mode is the best measure of center in this case. Okay. The next part is going to be about calculating the weighted mean and the mean of grouped frequency tables. So when you have a large data set that has multiple values with repeats, grouping the data and calculating a weighted mean can be time saving. So I'm going to walk through this and I'm going to explain this using the example here of the data that we looked at on how many months patients wait on the transplant list. So you can see there's lots of data points here that had repeats. So instead of typing in this huge data set, we could just make a list of possible outcomes. So that's our data value here in column 1. So we had an outcome. We had one data value of 3. We had the data value of 10 months. There were 5 people that waited 10 months. All the way down to, there were 4 people that waited 24 months. So you're going to put the data into a table with the first column being the possible data values. The second column will be the frequencies of each of those data values. The third column will be the product. So you're going to multiply columns 1 and 2 together. And I showed that here in my table. So I took column 1 times column 2. Then it says add the product column number 3 and divide by the total number of data values, which is the total number of column 2. The result is your weighted mean, or the mean if you would have used the original large data set. So you can see at the bottom of your page there, the weighted mean is 544 divided by 39 values. We totaled the number of values, and then we totaled up our products here, and it was about 13.48 months. And I think our data is just a little bit different. I think I had a couple extra values here than we did. It was similar data to the transplant. Okay. Now, sometimes we have data that we don't have the raw data, but it's already been put into groups, into classes, like what we worked on in our histograms, and I think it was lesson 2.1 and 2.2. So you're going to put the data into a table with the first column being the possible values. So that's going to be your classes, your grouped classes. Like we have here, these are classes. And then it says, since we don't know the individual data values, we can instead find the midpoint of each interval. So there's two different ways you can find the midpoint. The book says to find the midpoint by taking the lower boundary and adding the upper boundary and divided by 2. Okay, but sometimes the upper boundary, notice how it's a decimal. Then in that case, I would find the midpoint by taking the lower boundary of the current class plus the lower boundary of the next class and dividing by 2. And that's what I'm going to do here. So this midpoint is going to be 0 plus 3.5 divided by 2. And then we'll go to Desmos. And we will see that I calculated my first midpoint at 1.75. And then the next one was, I'll do the calculation down here. It was 3.5 plus the next lower boundary, 7.5. And then we're going to divide by 2. And so that's 5.5. So you can see I put that into the table here. 5.5. So I'm going to go back to the paper for a moment so you can see how I'm going to fill those out. Now, you can also see from your table over here that there is a difference of 3.5 is the width here, but then the next class has a difference of 4, and the next one has a width of 4, and then the next one has a width of 4. It's just that first one had 3.5. So we have 1.75, 5.5, 9.5. Add the width of 4 and we get the next midpoint at 13.5. Add the 4 and we get the next midpoint at 17.5. Then it says on our directions here, then the second column will be the midpoints of each of those data values. The third column will be the frequencies of data that fell into the class, which we were given that. We had 3 teenagers that played between 0 and 3.499 hours of video games. We had 12 teenagers that played between 7.5 and almost 11.5 hours of video games. That's a lot. And then we're going to take and multiply the midpoints times the number of teenagers. So I did this for you in Desmos so you could see that it can be done there. So I typed in my midpoints in X3. I typed in my frequencies in Y3, and then I multiplied my X3 and Y3. I let Desmos do that for me. And then you're going to total up your column, your X3, Y3, your product column, and divide by the total of your frequencies in Y3. And so the mean, approximate mean is about 7.8 hours that teenagers spend playing video games. And it's approximate because we don't have the raw data. We have a midpoint that is representing our raw data. Okay. The next example we have is here. It says find the mean of the following grades. So again, we don't have our raw data. We just have our data in classes. And I am again going to use the lower plus the next lower divided by 2. So it's going to be 49.5 plus 59.5 divided by 2. I'm going to go to my Desmos here so that you can see that. And so my first midpoint is 54.5. And then it looks like the classes are going by 10 for a width. And so that means that my midpoints are going to increase by 10. So the next one is 64.5, 74.5, 84.5, and 94.5. And then our frequency is 2, 3, 8, 12, and 5. And then to find the mean, we're going to total the product of X4 and Y4. And you don't have to make another column for that. You can just tell to do that. Total the X4, Y4, and then divide by the total of Y4. And so on average, the grades were a 79.5. And so let's go ahead and I'll show you how we'd write that on our paper here. On average, the students scored make sure I got the right thing. It was 79.5 on the exam. I'm going to say percent on the exam. So the midpoints times the frequencies are in Desmos. You can find them there. And that is all the practice for lesson 2.5. Catch me back for lesson 2.6.